Hi, this is a video on review on calculus. We are not going to do the basics of calculus, like I'm not going to do the derivatives of these things, x power, and these are something that you are supposed to have known before watching this video. So these are the functions that you should have known on how to find the derivative of, like x power n, the derivative is n x power n minus 1, etc. All these functions are presumed knowledge for this video, so you should have known how to find the derivatives of these functions. Once you are thorough with this, you can come and watch this video. This video actually starts with application of calculus. First of all, application of derivatives. Okay, we'll start with derivatives. Application of derivatives. Basically speaking, there are some 3 or 4 applications. The first one being finding the tangent and normal to a curve at a particular point. So when a curve's function is given, say f of x, and x at x is equal to x1, how do you find the tangent and normal? You know what a tangent is? A tangent is a line which touches the curve, and the normal is at that particular point, the perpendicular to the tangent is called the normal. Okay, and this is tangent, and this is well known. How do you find it? The first step is to find the derivative at x is equal to x1, which gives you the slope, and then you can use this formula or any other line formula where you have x1 and f of x1. The points are there and the slope is there. So a point and a slope is given, and you know how to find the equation of a line. So once you are done with this, if you have simplified this in the form of x plus some y plus some c equal to 0, this is the norm. This is a very general form of a line. So if you can write it in this way, or if you can write it like y equal to mx plus c way, in either way you can express the tangent. Okay, once you are done with this, to find the normal equation of the normal, whatever m you have got here, you just change it to negative 1 over m, and then use the same thing, but here it is negative 1 over m x minus x1. Okay, we can do one problem on this. Let's consider this example. Find the tangent and normal to the curve f of x equals 2x squared plus 3x minus 5 at x is equal to 2. First you find the value of f of x at x is equal to 2, which would be 2 times 2 squared plus 3 times 2 plus minus 5, which would give you 9. So this is the point 2 comma 9 is going to be our point, which is x1 y1, and then we are supposed to find what is the derivative, which would be 4x plus 3, and at x is equal to 2 it would be the slope at x is equal to 2, which would be 4 times 2 plus 3, which is 11. Okay, so m is 11 and you have the point 2 comma 9, so y minus 9 equals 11 times x minus 2. On simplification, this would be 11x minus y minus 13 equal to 0. This is the equation of the tangent. In order to find the equation of the normal, you take the same thing, but here it is negative 1 over 11 times x minus 2, and you can simplify this further, and then you get the equation of the normal. And this is the method to find equation of tangent and normal using derivatives. Now we will talk about increasing and decreasing functions. This is also called concave up and concave down. So an increasing function looks like this, a decreasing function looks like this. So in this case, you can see that the slope is positive, right? Slope is with the x-axis. The slope is positive. If the slope is positive, then you have an increasing function. If the slope is negative, you can see this is obtuse angle, tan of an obtuse angle is negative. If the slope is negative, you have a decreasing function, which means the derivative is positive here and the derivative is negative here. And we call this as concave up and concave down. This is concave down. So using this property, you will get maximum and minimum for a function. So how does it work? When the curve goes up and then starts coming down, you get a maximum. And the other way around, when it was concave down and then becomes concave up, you get minimum. So this is how you get maximum and minimum. And as you can see, this part, f of x is positive, f dash of x, the slope is positive, and in this part the slope is negative. So at the point where it is maximum or minimum, the slope is f dash. The slope, which is f dash x, is equal to 0. Even here the slope is negative and here the slope is positive, and therefore at this point where it changes, the slope is equal to 0. So this is also called stationary points. Why? Because the first derivative equal to 0. At the point where the first derivative is equal to 0 is called stationary point, and the point is this one, say x1, this point. Okay, the point, the x value for which f dash of x is equal to 0 is called a stationary point. So for both maximum and minimum, the first derivative is equal to 0. So how do you say which is maximum and which is minimum? So for maximum, it changes from positive to negative. Remember this, positive to negative is maximum and negative to positive for f dash x is minimum. So this comes like this and this goes like this. So you have a maximum here and you have a minimum here. So this is the criteria for which you can identify for this particular x for which f dash x equal to 0 whether that x is a maximum or a minimum. That is, the point before that should have a positive and the point after that should give you a negative first derivative, whereas in this case the point before x should have a negative first derivative and a point after x should have a positive first derivative. We can do an example on this. Let's consider this example. Find the maximum and minimum whatever is available for this function f of x is equal to x cube minus 27x plus 1. Okay, for this function you need to find the maximum or minimum, whichever is applicable here. So the first thing is you need to find the derivative function, which is 3x square minus 27, and you need to put this as equal to 0, which means that 3x square minus 27 equal to 0. Therefore x is plus or minus 3. Therefore there are 2 points, one is for 3 and the other one is minus 3. So in your graph the function should have a maximum or minimum either at minus 3 or at 3. Okay, we don't know which one is what. We can have a minimum at minus 3 and maximum at 3 or vice versa. So we need to find out what happens here. So we need to look for a number which is on both sides of each of this. That is, we can take x is 2 and x is 4, or we can take x is negative 4 and negative 2. So let's see what happens for these numbers. What happens to the derivative, first derivative, f dash of x. Okay, so the first one we need to find what happens to f dash of 2. F dash of 2, f dash is here. F dash of 2 would be 3 times 4 minus 27, which is negative. You don't even have to find the values there. What happens to f dash of 4, which is 3 times 16 minus 27, which is obviously positive, which means that around 3, which is 2 and 4, this is negative and this is positive. Therefore it comes like this and it goes like this. Therefore there is a minimum at 3. Therefore x is equal to 3 is a minimum point. Okay, if you are asked to give the coordinates, then you need to give 3 comma and you need to substitute in this, and then you have to give the value in coordinate form. Okay, and what about negative 3? So you need to find what is f dash of negative 4, whether it is positive or negative. So this would be 3 times 16 minus 27, which is positive, and f dash of negative 2 would be 3 times 4 minus 27, which would be negative. Therefore it's positive at this point, which means it's going like this, and it's negative at this point, therefore it's something like this. So obviously this is a point where it has a maximum. Therefore, x is equal to negative 3 gives the maximum point. So this is the simplest application of derivative of a function, finding the maximum and minimum and finding tangent and normal. We can also find the maximum and minimum using second derivative. So when you have a maximum, the f of x is positive, it is 0, and it's negative. So it goes from positive to 0 to negative. So which means that this is f dash x. So f dash x is decreasing, right? F dash of x starts with a positive, goes to 0 and negative. Therefore, f dash x is decreasing. For a decreasing function, we saw that if f of x is decreasing, then f dash of x is negative, right? Therefore, if f dash x is negative, the first derivative is decreasing, then its derivative, which is the second derivative of the function, is less than 0. Therefore, if you have f2 dash of x less than 0, then you have a maximum. In the other case, when you have a minimum, the function f dash x starts from negative. Here it is negative, here it is 0, and here it is positive. So it's negative to 0 to positive, which means it's increasing. If f dash x is increasing, its derivative, which is f2 dash x, is positive. Therefore, if f2 dash x is positive, you get the minimum point. So instead of using two numbers before and after for each number, you can just find the second derivative and check whether it is negative or positive for that particular value. We'll do it in the same example. F dash x is equal to 3x squared minus 27. Therefore, its second derivative would be 6x. So what happens for x is equal to 3 and what happens for x is equal to negative 3? When x is equal to 3, f2 dash of 3 is 18, which is positive, and negative 3 gives you minus 18, which is negative. So for positive, I said it's minimum. For x is equal to 3, you get the minimum value. For x is equal to negative 3, you get the maximum value. And this is the same result which we got by using numbers before and after the stationary points. I told you this is a stationary points when f dash x is equal to 0. So for each stationary point, we found out the f dash x before and after those points, and then we concluded which is minimum and which is maximum. The second way of doing that is going into the second derivative and checking for which point it is positive and for which point it is negative, and by these conditions you can say which point gives you the maximum and which point gives you the minimum. So when you are asked to find the maximum and minimum point, it's not enough if you stop with this. You need to go further either in this method or in this method and say which one is maximum or minimum. In some questions you might have, like we'll be doing it soon, you might have to just say find the value of x for which the area is maximum. So in these cases, we usually tend to stop with finding the x values, and we usually do not go further to check whether that x value actually gives the maximum or not. But it is very important, once you find the x values using f dash x equal to 0, once you find that, then it is very important to check whether that particular x value is maximum or not, or it is minimum or not, even if the question is not asking for the second part, that is, even if the question asks only for the maximum area or the minimum area. But it is very important to check whether the x value you got actually gives the maximum area or not. Another important application of the derivatives, which is called point of inflection. You can use x there or ECTION. What is point of inflection? For maximum, we said the function goes from positive to negative or negative to positive for maximum or minimum. But for point of inflection, it goes from positive to positive and it just turns like this, either this way or this way. So it's actually positive, positive, negative, negative. So what happens here, it actually changes its direction little bit and starts going in the same positive way instead of going to the negative part, or the other way around. So this point where it changes its direction is called it's called point of inflection, where it doesn't actually change the direction, but it goes continuously, but there is a change in its slope. So what happens for point of, there are two types of point of inflection. One is stationary point of inflection. One is obviously non-stationary point of inflection. So what does it mean? Stationary point of inflection is when you have a horizontal um, tangent at the point where it actually changes. Okay, so this means that here the f dash x is equal to 0. I told you f dash of x is equal to 0 gives stationary point. So even here the inflection point of inflection is when, stationary point of inflection is when f dash x is equal to 0, which means graphically the horizontal at the point of inflection is horizontal. What is now non-stationary point of inflection? Like in this case, if you see, if you can draw a tangent, you can see that it is not horizontal, right? If in this case f dash of x is not equal to 0, but still there is a stationary, which is there is an point of inflection. So there are two types of point of inflection, but what is the main condition for a point of inflection? So here f dash x maintains the sign before and after the point. That is, f dash of x is either positive when x is less than x1 and x is greater than x1, and if this is both negative for both the values, either it is both negative or both positive, that is positive positive here and negative negative here. So it is either both negative or both positive. So in that case, if the sign change is in this way, then we say that the point which is x1 is a point of inflection. And along with this condition, if you also have f dash of x1 equal to 0, then it is stationary point of inflection. We have seen how to use the sign change method for finding the point of inflection. We can also use the second derivative. If the function is something like this, okay, so what happens here is when you look at the tangents at this point, the tangent is decreasing, I mean the value is decreasing, and at this point the value starts increasing. So the tangent, the slope is decreasing here and the slope is increasing here. Therefore, the f dash x is actually decreasing and then increasing, which means f dash x has a minimum at the point where there is a point of inflection in the curve. So at this point, the derivative of f dash of x will be equal to 0. So I think this is clear. The tangent starts decreasing here, the slope is decreasing here, therefore f of x is smaller here and f of x is bigger here, f dash x is bigger, the slope. So it is changing from smaller to the bigger value. So it is decreasing, actually it is going smaller and smaller, and then it is becoming bigger and bigger as it moves up. Therefore at a point it has to change, where it has to be equal to 0. Therefore at that point its derivative, which is f2 dash, the second derivative of the function, is equal to 0. Therefore when the second derivative of the function equal to 0, and when f dash x equal to 0, we get stationary point of inflection, and when f dash x is not equal to 0, we get non-stationary point of inflection. But there are always exceptions to this. You can't just rely on f dash x is equal to 0. It's always better you use this sign change for point of inflection. For example, if you have y equal to x to the power of 4 and the curve looks like this, there is no point of inflection. But when you use this, f dash x is equal to 4x cube equal to 0 gives you x is equal to 0. You have a stationary point, and f2 dash x is equal to 12x square, which is equal to 0, gives you x is equal to 0, and you have f dash x equal to 0 and f2 dash x equal to 0, which is this condition, which should give us theoretically a stationary point of inflection, which is not when you see the curve, right? So when you see the curve, if you had taken say f dash of -1 and f dash of positive 1, that is a point before and after, you could have noticed that both are positive. Both have the same value. What is f dash of negative 1, which is here minus 4, and f dash of 1 is 4. So you can see that it is from negative to positive, which means it is not a point of inflection because it changes sign. So you cannot be very sure about this condition for finding the point of inflection. It is always better to go for sign changes before and after. So how will you find a non-stationary point of inflection? Let's consider this example. F of x is equal to x cube minus 3x plus 5. What is f dash x? 3x squared minus 3. And f dash x equal to 0 will give us x is equal to plus or minus 1. So which means that plus or minus 1 is are stationary points, because it gives us f dash x is equal to 0. So these two are stationary points, and we need to see whether this stationary point is going to be a maximum or a minimum or point of inflection. So let's go for point of inflection. What happens with f2 dash x, which is 6x, and when f double dash x is equal to 0, we get x is equal to 0. So we get a point of inflection at x is equal to 0, but we need to check whether it is actually a point of inflection or not. So how do you check this? So we need to find f2 dash of negative 1 and f2 dash of positive 1. So we need to check whether it is positive or negative before and after. So what happens for negative 1? Negative 1, it's we need to check it for f dash of x. So we need to find the sign change. For that, we need to consider the first derivative before and after 0, say negative 1 and positive 1. What is the value for f dash x for negative 1? You can see that it's going to give us both the same answer, which is 3 minus 3, which is equal to 0. So let's not use minus 1 because it gives us 0. Let's use, say, for example, negative half. We need to have some number before and after 0, okay, as close as possible. What about this? 3 times 1 over 4 minus 3, and this is 3 times 1 over 4 minus 3. What we want to know here is they have the same sign, same value, in fact, right? So they have the same value, therefore it has to be a point of inflection, because for point which is maximum or minimum, then there should have been a change in sign. Since there is no change in sign, we have the point of inflection for x is equal to 0, because this is something we took on both sides of x is equal to 0. Because this is a special case, we cannot judge anything on that. So we took another number, a negative and positive half. So what about this? You can easily say which one is positive and which one is negative. We can see what happens to negative 1 and what happens to positive 1 for the second derivative. For negative 1, it's obvious it's less than 0. For positive 1, it's more than 0. Therefore it is there is a sign change from for this, which when it is negative, when the second derivative is negative, you have the point to be a maximum point. When the second derivative is positive, the point is going to be minimum. You can just check using two numbers on both sides of this and finding f dash x on both sides, as we did before. You can check it and see if they really give the maximum and minimum, as we just found out.